In Stuttgart, we apply the high-resolution spectroscopy methods of macQsimal to detect tiny amounts of nitric oxide molecules that are held in a vapor cell that contains a background gas. With the usage of several laser excitations, we can specifically excite only nitric oxide in these vapor cells to a highly excited quantum state, which we call a Rydberg state. These Rydberg states are very fragile, and any collision within this vapor cell rip them apart into charged particles. The charged fragments of the highly excited molecules produce a tiny but measurable current, and this is the new way to detect specific molecules. The implementation of such a new technology to measure trace gases in vapor cells raises, of course, many fundamental questions. For example, how well can we really select one of those types of molecules for detection? What are the best conditions for ionizing collisions? And how do we get all our valuable charges after fragmentation in the vapor cell onto these electrodes to count their number? And finally, what is the fundamental detection limit?
Our method to detect a handful of molecules hidden in a gas of billions of other particles is a quite novel idea, and we are on the way to build a demonstrator that this method can outplay commercially available nitric oxide detectors. Especially the laser systems we use are only available since a few years, and they are a little bit bulky. But here we have to keep in mind the rapid developments in technology, and in a few years all this equipment might fit into a small shoebox-sized thing. So far we have succeeded to miniaturize the spectroscopy cell where the gas mixture flows through and the electronics to pick up the ions. The smaller the whole assembly of spectroscopy cell and electronics get, the better we can detect the molecules in question. For now we have a device in the centimeter scale, but soon we will be able to reduce this to the millimeter scale. Why do we need such small, efficient and fast detectors for molecules? Nitric oxide is an important tracer gas for inflammatory diseases like asthma. If the nitric oxide concentration in exhaled breath is too high, one might be affected. For humans, we have devices to test for this, but medical research relies on mice.
The goal of this project is to do gas analysis on the exhaled breath of mice, which of course have a very small volume, but on the other hand, mice also breathe very fast. So this means we have to have a detector which is fast enough to really have an in-time monitoring of the exhaled breath of a mouse.